Okay, good morning. Today's we will discuss about subnetting and CIDR. So, what is CIDR? Classless Interdomain Routing Protocol, right? So, why we need CIDR? Then, class full address. In class full address, we have class A, class B, class C, class D. So each and every class we have number of host ID will be separate, number of network ID will be separate. Based on that only we can able to build any network, right? Suppose I need only few IP address in the network. That time, so most of the IP address will be wasted while using classful address. That's why I need what? CIDR. Okay. So CIDR is nothing but what? Classless interdomain routing protocol. The format for CIDR, the classful address generally we are using A dot B dot C dot D. Okay, which represents what? IP version 4 byte information. Once we have the format like this, A dot B dot C dot D slash N, okay, this is kind of what? CIDR, which represents what? CIDR IP address. Because from the first byte, so unable to identify whether it is class A, class B, class C. No need to identify it. So based on this number, N represents what? How many network address or block ID. Block ID or network address both are same. Okay. Say for example here N is nothing but for example 28. So 28 bit we have block ID or network ID. Right, totally 32 bit, 32 minus 28 equal to 4. So 4 bit will be considered as what? Host ID part, right? So anyway, we are going to identify how many bits we have net ID or block ID or how many bits we have host ID. But we will never consider class A, class B, class C. Okay, like that. Okay, assume that this is kind of network. From this network, I need some block of IP address. Okay, how to get block of IP address? Okay, from the given IP address, given network. So for that, we have certain rule. Whenever the rule is satisfied, we have what? CIDR. Okay, there are 3 rules already framed. One is what? Say for example, they are given list of IP address. All the IP address should be contiguous. Say for example here, 100.1.2.32. Okay, 100.1.2.33, 100.1.2.34, and so on till 100.1.2.47. Okay, just you should identify whether all the IP should be contiguous or not. Yes, 32, then 33, 34, and so on. So series number we have, right? Sometimes we have 32, then 34. This is not comes under what? CIDR. So all the given IP should be contiguous. Then only it is considered as what? CIDR event, right? Here the number of the range for IP will be here what? Say for example the block ID or IP network ID will be here 16. This value should be the power of 2. Power of n. Say for example here the next rule in CIDR will be what? No, all the range of any IP should be the power of 2. Okay, 2 to the power n. N is nothing but what? Number of block ID or network ID, right? Say for example, the number of IP address in this given IP is what? 16. So 16 is nothing but 2 to the power 4. 2 to the power 4. So 2 to the power 4 is nothing but 16. It satisfies the rule for what? CIDR, rule 2. Okay. So in this example, you are going to consider how to get 2 to the power n. So now it satisfies the rule also. So both the rule will be satisfied for this example. Consider third rule. The first IP address, first or block ID in the given range of IP always evenly divisible by the size of the block. Okay, evenly divisible by the size of the block. Say for example, the given number is 1, 2, 3, 4. Assume that 2 to the power, for example, 1. Okay, so this is least significant bit. Here the remainder will be 1, 2, 3. Quotient will be here 1. Like that you are going to divide the number. Okay, so this is one example. And all the range of IP should satisfy all 3 rule. Rule number 1 will be what? All IP range should be contiguous. Okay, after that we have some list of number that should be the power of 2. Power of 2, that is 2 to the power n. Then the third rule will be what? The first IP address given in the list always evenly divisible by the size of the block. Okay, so this is the rule for what? CIDR. Okay, now let's consider one more example. Here the first address will be here what? 100.1.2 point. Here 32 should be converted into what? Equivalent binary here 0010 then 40, right? Here 2 to the power 4. Here the host ID part will be here what? 4 bit here. Okay, the remaining bit will be what? 32 minus 4 equal to what? 28, which represents what? Block ID or network ID. That is 100.1.2 point. Here 3 bytes, 3 into 8 equal to 24, 24 plus 4 equal to what? 28. So 28 block ID we have in the given range of IP. The first IP address you are going to consider here. The last 4 bit always considers host ID part, right? Host ID part, this should be divisible by always what? The size of the block, right? Now check it now. The host ID will be always what? 2 to the power n. N is nothing but what here? 4. 4 is nothing but host ID part. So the rest of the bit will be what? Totally we have 32 bit. So here block ID equal to 32 minus 4 equal to what? 28. Okay, so how to represent in CIDR given? Okay, here the first IP address will be what? 100.1.2.32/28. Okay, this is the way of representing any IP in CIDR. Okay, 28 represents what? 28 ones we have in block ID part or net ID part. Okay, the rest of the bit considers the host ID part. Okay, even we can take any IP in the given range, right? Then from that we can able to identify what are the range in the given IP also. Everything we can able to calculate it, right? So this is a format for what the given list of IPs. Okay, that consider next example here. Now let us consider another example. 20.10.30.32. Then 20.10.32, 30.33, okay, 33, then 34 and so on till 63. Assume that, right? Now whereas without CIDR, from first byte itself, suppose once we are identifying means it is class A, we will never consider any classes here. Directly we can able to identify whether it satisfies the rule of what? CIDR based on this rule or not, right? Now 20.10.30.32, 33, 34 and so on till what? 63. Okay. Now how many IP addresses we have in this list of IP? Okay, the list of IP will be here what? Totally 32 IP address given in this example. Okay, 32 is a list of IP address should be contiguous one, because after 32 then 33, 34 and so on till what? 63. It satisfies the rule 1 in CIDR. That is all IP should be contiguous, right? It satisfies the rule. So that this is one of the comes under CIDR because it satisfies the rule 1. Then the 32 can be represented what? 2 to the power 5 equal to 32, right? So how it should be the power of 2 to the power n. 2 to the power n. So here n is nothing but what? Here the 5 represents what? How many host ID part we have in the given IP. Okay, host ID part in the given IP. Now consider, so total number of bits will be here 32. 32 minus host ID part will be 5. That is nothing but what? 27. Okay, 27 represents what? Block ID or even network ID. Block ID or even network ID. Okay, is it clear? Now what happened here? So the first address always evenly divisible by the size of the block here. Consider this IP. Okay, you are going to take any IP given here. So 20.10.30, for example 32. So you should convert into equivalent binary here. Okay, so equivalent binary for 32 will be what? 001 then 5 zeros. Okay, so how many bits considers network ID or block ID? 27. Already 24, 25, 26, 27. Up to this will be considered as what? 28 bit, right? So here what happened? 27. Okay, block ID part will be here 27 here. Okay, 27. The rest of the byte bit always what? 0 here. Okay, then what? Then 33, 34 and so on 63. So we will never change any, we will never make any change in the block ID or network ID. Only you can derived from the host ID part. Okay, the host ID part always you are going to take a continuous number you can generate, then only you are going to get the sequence of contiguous number. Okay, so this is an example. Okay, consider the another example here. 150 point 150 point 10 point 20 point 64, then 65, and so on till 127. Okay, the rest of the bit will be same. Okay, so what is the range here? 127 minus 64 plus 1, that is 64. Okay, 64 IP address they are given. So this is all the IP should be what? Contiguous. So it is satisfy the rule number 1. Then what? After that you can identify whether it is what? The power of 2 or not. So 64 is nothing but what? 2 to the power 6. 2 to the power 6 equal to what? 64. So the 6 is nothing but here what? Host ID part. Host ID part equal to 6. The remaining bit will be what? Block ID or network ID, that is 32 minus 6, that is equivalent to what? 26. Okay, 26, which represents what? 26 block ID or network ID we have. Okay, so that you should write like this. Okay, just you are going to check it whether it satisfies the rule of what? CIDR or not. So that you are going to discuss a few example. Okay, it satisfies all the 3 rule, it comes under what? CIDR, right? Now how to represent all the range of IP in CIDR now, right? So see one more example here. 100.1.2.32, 100.1.2.33, 100.1.2.34, then 100.1.2.35. Okay, and so on till what? 47. Okay, 47. The range for IP will be here what? Simply you should write 47 minus 32. Okay, plus 1, 5, 6, remaining 6. So 16 IP addresses. Okay, whether all the 16 IP addresses will be contiguous or not? Yes, it satisfies the rule. Okay, so that it is what? It comes under CIDR. Then what? How to calculate host ID part as well as block ID or network ID from this number? Okay, so 16 is nothing but what? The power of 2. That is nothing but 2 to the power 4. 4 is nothing but what? Host ID part. Okay, in a host ID part only we have what? 4 bit. Okay, the rest of the bit will be what? Block ID part or network ID part. Here 32 minus 4, nothing but what? 28. Okay, 28 bit. So that any IP in the range can represents in the form of what? A dot B dot C dot D slash N, that is 100.1.2.32 slash 28. 28 represents what? Number of block ID or network ID. Okay, that is 28 bits 1. Okay, all 28 should be 1. The rest of the bit will be considered as host ID part, which indicates, okay, N represents what? Network ID or block ID. The rest of the bit will be considered as what? Host ID part, right? It is even any IP range. Okay, they are given for any subnet in a classless interdomain routing. Here the first address is always used to identify the network, okay, or block. Okay, network or block. It is similar to what? Classful address in networking. Okay, the last IP address mainly used for what? Default broadcast address. It is similar to the previous topic, right? So here assume that we have 16 IP addresses. The useful address will be here what? 16 minus 2. So only the used IP address here will be 14. The same way here the total number of IP will be 32. Even though we have 32, what happened? We will never use 2 IP addresses. Why? The first IP address should be used to identify the network. The last IP address can be used to identify the broadcast information, right? So the remaining what? 30 IP can be useful for used for our networking. Okay, so same way here we have total number of IP in the range will be here 64. Okay, which can represent 2 to the power 6. Okay, even though we have 64 IP addresses, the first IP can be used for what? Identification of network. Okay, upper 64 minus 2, the useful IP address here only what? 62. Okay, 62. The same way the last IP address can be used for what? Default broadcast IP. Okay, default broadcast IP. The same way, consider here the list of IP here also. The first IP can be used for identification of what? Identification of block or network. Okay, the last IP always what? Identification of what? Broadcast, default broadcast IP, default broadcast address. Okay, so total number of IP in this given range will be what? 16. 16 minus 2 equal to what? 14. The useful IP address in this range will be only 14. Like that you should identify it. So far we discussed whether they are given list of IP, whether it satisfies the role of what? IP for what? CIDR. It satisfy all the rules here. All IP should be contiguous. All the contiguous numbers should be what? The power of 2 to the power n. Then the third rule will be what? The IP, first IP address always should be divisible by the, evenly divisible by the size of the block. Okay, based on this you are going to what? Represents CIDR. Okay, so far we discussed only we are considering the first address. Okay, first IP address in the given range. Okay, now you are going to consider, take any IP range, right? So out of this you are going to take the middle of any IP. Now you are going to generate all the range for the given number, right? Say for example here instead of taking 32 or any numbers here, now choose any IP here. Now you are going to choose any number because the starting IP address will be 32. So from this to this you can choose any IP here, 35. So 20.10.30.35. Okay, so here. Okay, from this example you are going to take. Otherwise you can take here also 100.1.2.34. Okay, 34 is not starting IP address for the given range. You are going to take any IP here. Okay, after taking this you are going to use number of bits in the net ID or block ID part will be here what? Here 16 to the power 4, then remaining will be what? 28. So here you should write 28. Okay, now you should take 28 represents always what? Block ID or network ID. Okay, 4, 8, 16. Okay, 16, then 24. Okay, so here you should take the partition will be happen in the 4th byte. Okay, so that you should write 100.1.2.34. 34 equivalent binary will be what here? 8421, like that you are going to consider here 16, 32, 64, even 128. Okay, here 34, 32 plus this one. Okay, here 0, 0, 1, 0, 0, 0. Okay, then what? 1, 0. Okay, okay, 32 plus 2 equal to what? 34. This is equivalent binary for what? 34. Okay, because 24 block ID or network ID where the split will be happen in the 4th byte. Okay, 100.1.2.34. Okay, but how to generate the range for this one? Okay, this one or this one? Okay, so 100 point, okay, 1 point, 2 point. Okay, so here 28 bit, so 24, 26, 27, 27, 28. Up to this you are going to consider block ID. The rest of the bit will be considered as what? host ID. Host ID part always should be what? 0. Always should be 0. Okay. Then only the first IP in the given range should be divisible by what? Evenly divisible by the size of the block, right? Then what? Then you are going to generate the sequence of number here, right? So 100.1.2.0010. Now 0000. Okay, this is what? 32. Okay, this is what? 32. Then what? 100.1.2.0010. So up to this, don't make any changes because it is net ID or block ID. Only you should make changes in the host ID part, right? We will never do it in the network ID part. Here 01, it represents 33. Then what? 0010, 34. Okay, here 0010. Then 2, 3 means what? Here. Okay, here 35. Okay, 35, 000010. Then what? 36, 100 here. Okay, 0010, and so on till 0010. Up to this considers block ID part. Okay, so all the host ID part should be all ones. Up to that you are going to what? Make a generate the IP address here. So from 32 to till 47. Okay, 47. So now even though we are taking any IP from the range, we can able to generate the actual range in the given problem. Okay, so the starting IP address in the given IP address will be what? 100.1.2.32. Then what? 33, 34. But even though we are taking what here? 34. 34 is what? The middle of what? The IP range. But we are taking from where? We can generate from first IP to last IP. Okay, so now you are going to take what? The same thing. You are going to consider any IP address here. So 100.1.2.35 slash as usual. So here 28 bit or any IP address, always 28. 28 bit should be considered as what? Are represented as net ID part or host ID part. Okay, the rest of the bit always considered as what? Host ID part, right? So even we can generate what? Even though we are going to consider any middle IP, we can able to generate from first IP to till last IP. Then you are going to consider whether all the 3 rule will be satisfied or not. All right, what are the 3 rule? All the IP should be contiguous. If it is contiguous, it satisfies the rule number 1. All the range should be the power of 2 to the power n. Okay, n is nothing but in this example number of host ID part, right? After that you are going to take the first IP address in the range, always evenly divisible by the size of the block. Okay, so anyway, after generating this, still it satisfies the all 3 rules, so that it is what? CIDR. Okay, now consider one more example here. One more example. Start with, for example, in this IP we have already list of IP here, 20.10.30.32, right? So from this we are going to generate the range from 32 to till what? 63. Okay, but even though they are given sequence of IP, you are going to take the middle of any IP here. Okay, middle of any IP here. Say for example 20.10.30.35. Okay, 30.35 here. .10.30.35/27. Okay, this is starting address in this range? No. Okay, so this is what? Middle of any IP range here. So you are going to take what? 20.10.30.35/27. Already we know that 27 represents what? Block ID or net ID part. Block ID or net ID part. Remaining bits will be what? 5 bit represents what? Host ID part. By default we know that already, right? Now how to generate the starting address to till what? Last address, even though we are taking any middle address in the range. Okay, so then only we can able to represent in CIDR. There is no issue. Here 27 what? 8 plus 8 plus 8, 24 plus 3 bit. The split will be in 4th byte. Okay, because 27 once we have. Okay, 27 once we have. After that only we have host ID part. So that all three first 3 byte will be considered as what? 20 byte 10.13. In 35 only we have the split. Okay, 35 only we have the split here. So 35 equivalent binary will be what? 001. So here what happened? 27 bits will be considered as net ID part or block ID part. We will never make any change in this. The rest of the bit will be considered as what here? 00011. This is equivalent binary for 35. Equivalent binary for 35. Okay, first because you should identify where the split would be occur. Okay, here even though we have 4 byte, the split will be happen in the 4th byte itself, so that the 4th byte should be converted into equivalent binary here, right? So 001 000 11. Anyway, number of bits will be here 8. The total number of binary again converted into decimal means it represents what? 35. No issue. Now how to generate all the range in this? Okay, in this. So now you are going to take here 20.10.30.001. Okay, because we will never make any change. This is what? Block ID part. This is what? Block ID part. Okay, so all host ID should be 0. Should be what? 0. Then only easily we can able to identify the network. Then only after that only we can able to ID the host ID part, right? So the host ID initially can be replaced by what? 00000. 5 digits here. All the 5 digits should be 0. Okay. So here what is the equivalent binary for the last 8 bit? Okay. What is the equivalent decimal for the given binary? Okay, so all 8-bit binary should be represented here 32. Okay, where we will make some changes only in the host ID part. We will never make any changes in the block ID or network ID part, right? Now, so after 32, now you should write 20.10.30.001 up to this considers block ID. So don't make any changes here. Now you are going to write 1. Okay, 32 plus 1 equal to what? 33. Then what? 20.10.30.001. Okay, here 00010. This is nothing but 2. 32 plus 2 equal to what? 34. And so on till you are going to generate what? 20.10.30.001, then all ones. So totally 8 ones we have, right? Which represents what? 63. Which represents what? 63. From 32 to till what? 63 we can generate. Okay. Now you should identify whether all the IP. Okay, even though we are taking any IP in the given range, okay, not from the first IP, okay, still I can able to generate what? All the IP ranges here, right? After generating that, again you are going to check it whether it satisfies the rule of what? CIDR or not. The rule number 1 will be what here? The first address will be here 32, then 33, then 34 and so on till what? 63. The range for IP will be here what? From 0 to 63 represents what? 32 IP address we have. So 32 IP address will be what? Whether all the IP address will be contiguous or not? Yes. It satisfies the rule 1. Okay. After that, you are going to take all the IP range should be the power of 2 or not? Yes. Power of what? 2. 2 to the power 5 equal to what? 32. Right. So we will never use first and last IP by default because first IP can be used for identification of block ID or net ID. The last IP can be used for what? Default broadcasting. Okay, so we will never use it. So even though we have 32 IP range, the 30 will be used IP addresses. The rest of the two will be never used for any further communications, right? So it satisfies the rule, and also the power of 2, it satisfies the second rule also. The third rule will be what? The first IP address in the given range evenly divisible by the size of the block. Yes, this value should be divisible by the size of the block. It is also satisfy the rule of what? Even though we are generating any IP, here it satisfies the rule number 1, 2, 3. Okay, so we are taking one example from this. We are taking another example from this. Now we are going to take another example from here. Okay, yes. Now we are going to take one more example. On 50 point, 10 point, 20 point, 66. Okay, slash. Okay, 20. How many bits we have? 64. 2 to the power 4 equal to 32. 6. 2 to the power 6. Okay. 127 minus 64, 3. 64 range will be 64. 2 to the power 5 equal to 32, 6 equal to 64. So here what happened here? 32, 26. Okay. Yes, 26. So what is the meaning of this? Here 150.10.20.66 slash 26. Okay, 26 represents what? A 26 block ID or net ID. Okay, the rest of the bit will be considered as host ID part. Okay, the host ID part will be here 6. Okay, then how to generate the range for all the IP here? Okay, even the spread will be what? And the fourth byte itself. So this decimal should be converted into binary. Then you should generate from first IP to last IP. Then you should validate whether it satisfies the rule of what? CIDR, rule number 1, 2, 3. Once it satisfies all the rules, then it is also called as what? CIDR. Okay. Okay, this is the concept about what? CIDR.